In episode 3, you wrote a Dockerfile and built your first image from scratch. This episode is about what's actually inside that image, layers, why their order matters, and how tags really work. Every instruction in a Dockerfile that touches the file system, from, copy, run, and a few others, creates its own read-only layer, and the stack of all of them together is the image. To see this for real, we're reusing the same technique from last episode, a tiny compiled binary and from scratch, so this demo runs with 0 downloads. This time we're adding a second file alongside our program, a small text file standing in for something that changes often, like your application's source code. Here's the Docker file. From scratch, then copy the app binary, then copy that version file, then cmd to run it. 2 copy instructions, 2 layers. This build output is captured from a real, live Docker build. Each copy instruction becomes its own layer, and the result is tagged myapp, version 1.0. Now let's look inside it with Docker history. 3 rows come back, newest layer first. CMD costs 0 bytes since it's just metadata. The version file layer is 8.19 kilobytes. The app binary layer is 791 kilobytes. Each row sits on top of the one below it. That's the stack. Oldest layer at the bottom, newest on top. Now watch what happens when we rebuild with absolutely nothing changed. Both copy steps come back marked cached. Docker checked each instruction's inputs, found them identical to the last build, and skipped redoing the work entirely. That caching is what makes repeated builds fast. Now let's change something. We edit the version file only, standing in for a normal code change, and rebuild. Look closely at this real output. Copy app is still cached. Only copy version.txt actually reruns. That's the payoff. Because the binary was copied before the file that changes often, its layer never had to be reconsidered. Now let's break that on purpose. Same 2 files, same 2 copy instructions, just flipped in order. Version file first, app binary second. We change the version file again and rebuild this flipped Docker file. This real output tells a different story. Neither step comes back cached. Not even copy app, and the app binary genuinely didn't change. Here's why. Docker's cache check for a layer depends on the layer built just before it. Once one layer's cache breaks, every layer after it breaks too, whether its own content changed or not. So the rule: order your Docker file from least likely to change to most likely to change. Base image and dependencies first, application source last. So a normal code change only invalidates the cheap final layers. One more real command before tags. Docker run myapp :1.0. And there's our program's actual output, printed from the container we just built and cached our way through. Now tagging. We run docker tag, pointing myapp 1.0 at a second name, myapp :latest. That command doesn't copy anything or build anything new. Docker images confirms it. Myapp 1.0 and myapp latest share the exact same image ID. 2 names, 1 image. That's why relying on latest in production is risky. It's not a promise of the newest version, just whichever image someone most recently tagged latest, and anyone can move that pointer silently. The safer practice: tag with something specific and permanent, a semantic version, a git commit hash, or a build date. Treat latest, if you use it at all, as a convenience alias, never a deployment target. Let's recap. A layer is created by every file system touching instruction. Docker caches layers and reuses them when nothing changed, and a cache break in one layer cascades to every layer after it, which is why instruction order matters. Tags, meanwhile, are just names pointing at an image ID. Cheap to create, easy to move, and only as trustworthy as the discipline behind how you assign them. That's episode 4. You now know what's inside an image, how instruction order affects caching, and how tags actually work. In episode 5, we cover volumes and how containers persist data across restarts. Subscribe so you don't miss it. See you then.